Hello everyone, welcome to the week 8 concepts summary video of Python. So you might not have seen any video for week 7 because that was basically a refresher week where there was no new content delivered, so we didn't make any video for that. So let's start week 8 where we have some very interesting concepts to discuss. So let me start it by writing a simple code which we all understand, right? So I'm just here defining a function which is nothing but just function to print natural numbers, which takes uh, input as n, which is how many natural numbers that we have to print. And it basically runs a for loop from, as we know, natural numbers start from 1. So we started from 1 and we go till the n. So for that, we have to basically mention n plus 1. And then we just print n, sorry, print I. So let me run this and see. Okay, so this is basically a definition of function. So if we run it, nothing appears. So we have to call this function now with some value, with some parameter. So, okay, print natural numbers of, let's say I want 8 natural numbers. So let's run this and see how. So as you can see, I got the first 8 natural numbers here. So, okay, nothing new here. So this is something which we all know. So, as you can see here, we here in this piece of code, we have used two variables, if you can see. One is this n, and one more variable is this I. So we used two variables to print the natural numbers. So uh, you can just pause this video and think like, is there any way to print the natural numbers using only one variable? Okay, so our goal is to print the natural numbers like the same as what we are able to see here with just one variable, right? So pause this video and think. Okay, now let me write a piece of code here. Uh, Let me name it print numbers, and the same, it takes the same input. And I'm writing something here which I'll explain. Okay, so here I've defined a function which may seem new to you. So it won't seem new to you after 5 minutes when I'll explain it. Okay, so now I'll just call this function with some parameter. Let's say, let's call it with 8 only. So what do you think the output will be if I run this code? Let's see. Wow, it's the same output that we are able to see, like the output of both of these codes is the same. So what is the new thing that we did here? As you can observe, you are not able to see any other variable other than n here. So we basically achieved our goal where we printed the natural numbers using just one variable. So what is happening here? So this is nothing but uh, first we took the parameter as n, and then if we are checking if that n equals 0 or not. Okay, so as we can see, this n is not 0. So it is going to this else condition where it is calling the same function with a parameter which is 1 less than this n, right? So it is not calling any other function. So it's calling, this function is basically calling itself. inside. So the function name is print numbers here, and it is calling the print numbers only with a parameter which is one less than the value of n. So this process where a function is being called in a function itself. So the function is calling, so in other words, we can say the function is calling itself with other parameters, which in this case is one less than the previous number. So this type of condition where the function calls itself, we call this recursion. Okay, let me mention it here. This is nothing but recursion. So we are recursively, so the basic meaning of recursion is that to do something repeatedly, to do some process repeatedly. So we are basically recursively, changing the values of n. And once this n value comes to 0, it returns nothing. So it basically breaks there. So we call this condition which is there here as a base case. Base case means nothing but a case, like a condition where the recursion has to stop. So for any loop, we have to define a place where it has to stop. So here in recursion, we call this a base case where if this condition is true, then the recursion stops there, or else it basically changes the value of n by 1 in each iteration, and at last all the function calls will be in a stack, and it starts executing the print with the n value from 1, because the last function call that we did was with the value 1. So it keeps on calling all the functions in the stack starting with value 1 up till the n that we provided, which is 8. Okay, so let me tell you the basic structure of how a recursive function will be. Okay, so just a second. Okay. So let's say we define a function with some parameters, and here we define a base case, correct? Here we define a base case, and then we write some condition, and the base case is also basically a condition where if that condition becomes true, the recursion breaks there. So here we do the recursive call. Let's say the name of this function is x. So here we call x only, right? So this is basically the function calling itself. So this will be the basic structure of any recursive function that you can see anywhere, right? So let us see some more applications of this what you call recursion. Okay. So let's say we want to find whether 0 is present in a given list or not. Okay, so for that we can write a basic function which finds 0 given a list L as input. And as we all know that the first thing that we have to do is define a base case for a recursive function. So our function should stop when the length of L is equal to 0. So till then it should go on. Okay, we'll return false when the length of L becomes 0. Uh, and if L of 0 is 0, let's say, that means the first element is 0. Then we return true. Okay, so now let me do something here. Okay, so as you all might know that this way of writing the list uh, thing is I am basically with this statement, I am basically telling that to take the input as list from starting from the first index. So which basically means, let me annotate that. Let's say we have a list called L with elements 1, 5, 6, 7. Let's say. So I write this. What does this mean? So I am basically telling that to take our list starting from the index 1. So as we know that the index of 1 is 0 and this index is 1, this is 2 and this is 3. So it basically takes the elements starting from the index 1, which are 5, 6, 7. Okay, I think you got it. Okay, now, so we are basically doing that, and then we, let's say, define a list numbers with some random numbers, and we keep 0 also in that, and we print find 0 of our numbers, right? Let me run this and see, as 0 is present here, it is saying true. So what is this actually doing here? So it is actually first checking whether the length of L is 0. So if length of L is 0, it returns false, or else it checks whether the first element of the list is 0. Okay. If it is true, then it returns true, or else it runs the same function with the list excluding the first element. Right. So here, because we have already checked here whether the first element is 0, so if the first element is not 0, we get rid of that element in the list. Right. So we check only the remaining elements of the list. Right. So if I remove 0 from this, what does it print? See, it basically prints false because it didn't find any 0 in our list. Okay. So this is an application of recursion. Right. So we can also basically see one more case where we can find this recursion. Uh, let's say I want to recursively sort a list of elements. Okay, I define the function and take list as parameter, and if I write the base case, if length of our list is 0, then return an empty list, or else what we do is we define a variable smallest, which is minimum of L, min of L, the least element in L, and we basically remove the smallest element from L, and we return this smallest element, and to the remaining list which is there, we recursively sort that, the remaining list, right? So let us define a list with some numbers which are unsorted. Okay, so I want to run recursive sort on these numbers. Oops. Right, so let me run this and see what it does. See, it did sort the elements in increasing order. So what is this basically doing here? So first the base case we check it, and what we are doing here in these three lines is that we are first taking the minimum, like the element with least value from the list L and storing that into a variable called smallest, and we are removing that element from our list. Okay, and we are basically returning a list with that smallest element in the first place, and then we are running a function which is recursive sort with the remaining elements of the list, excluding this smallest element. So in each iteration, in each recursive call, the first element will always be the smallest element which is present in the in our list. So basically, in that way, by capturing the smallest element and removing that and keeping that as a first element, we are achieving the sense of sorting the list, which we can see here. So it may take a bit of time to get a picture of what is happening behind it. So it's just that take some time and try all these codes with yourself. And through practice, you will get to know the picture of what happens behind the recursion. So it's not a very tough concept to understand, but it's just that it takes a bit of practice to get a bigger picture of what's happening. Okay, so now we have seen what recursion is with a few examples, and let me give you a case where, let's say, I have a few elements here in a list. In a list, I have some random elements. Okay, so this is my list where I have 1, 2, 3, 4, 5 elements, and I want to check whether this list has an element called 2 or not. So it's just simple. I have a list and I want to check whether this 2 is present in this list or not. So what is the way that you can think of to achieve this? So we can basically go through each, like we can run a for loop, which basically iterates through all the elements of this list one by one and checks whether the what do you say, that current element is 2 or not. Right. So it basically runs a for loop and checks whether the first element is 2 or not. So if it is not 2, then it goes to the next element. So it basically loops through all the elements of our list. So this is a procedure where we can achieve this, but through this procedure, so how many iterations will it take to reach 2? Right. So we have to go through 1, 2, 3, 4 elements, and then we'll find the element 2. Right. So we have to go through 5 iterations. 1, 2, 3, 4, 5. 5 iterations to tell that we 2 is present in that. So pause the video and think of any more efficient way, like more efficient way with which we can achieve this by using less number of iterations. Okay, so uh, one thing that I can think of is uh, let's say let's add one more element, uh, 5, let's say. Okay, so now this has 6 elements. Our list has now 6 elements. So from this, I want to check whether 2 is there in this list or not. So one way that I can think of is, first I can sort this list, right? So let's sort this and see. If we sort this, we have 2, 5, and then 26, 35, 42, and 89. Okay, this is a sorted L, right? Okay, so now we have to, I will do something. I will split this list into half. Okay, okay, I have split this list into half, and I'll check whether the middle element, like I'll capture the value of the middle element, right? And check whether the element that I'm searching for, the value of that, whether the value of the element that I'm going to check, is that less than the middle value of this sorted list or greater than the middle value of this sorted list. As we can clearly see that 2 is definitely lesser than 35. So we are sure that 2 will be present in the left half of this list, right? So we can ignore all the elements which are there in the right half of the list. Correct? So here what I'll do is I'll capture only this list which has elements 2, 5, 26. And then again I'll capture the middlemost element which is 5. And I'll check whether 2 is less than 5 or greater than 5. So we can definitely say that 2 is less than 5. So I will get rid of the these elements also. And which I'm left with is just 2. So here it took 5 iterations for me to tell that 2 is there in the list. But here it took only 3 iterations to tell that 2 is there. So this procedure what we did just now, this is called nothing but a binary search. Okay. So what we did here is called a linear search where we looped through all the elements one by one. But this is called a binary search. So binary actually means 2. So what we are doing here is we are iteratively splitting the list into 2 halves and checking whether the element that we are looking for will be there in the left half or right half. So if we say that it is in the left half, we are even more dividing that left half into 2 elements and then checking whether the that element is there in the left half of that left half or right half of that left half. So it's like that. We are recursively or iteratively splitting the list into half and checking whether our element is the left side is there in left side or right side of that split list. So we so today we have learned two concepts which are recursion and binary search. So is there any way we can combine both of these concepts and come up with a code? Let's see. Let's see a condition where we can mix both of these concepts. Okay. Now I'll write some code. Just observe what I'm writing, and it's totally fine if you are not able to understand what I'm going to write. It's completely fine. But I'll explain it, and then even if you don't understand after the explanation, please go through the code once and understand what that is doing and practice it. Then you'll get the picture of it. Okay. Let me start it by defining a function. Binary search. Target, then we return true that we found it. Or else if uh, target is less than the middle element, we basically return the binary search with the parameters, the same array and the same target, low and mid is 1, right? Else we return binary search with the same array, target plus 1 and 5, right? Let's define a list. let's say 6, and we start from 0 index and go till length of my list minus 1. Okay, so what did I write here? But first, let's just run this and see whether this works or not. Yes, this worked and this printed true. Okay, now I'll explain what is basically happening in this code. Okay, for now, let's just ignore the base case. Okay, so how are we defining this binary search? So we define this binary search and give it 4 parameters. Okay, what are these 4 parameters? So this is basically first one is the array. So the list of numbers that we have here. That is the first parameter here. And the target is that element which we are searching for in this array, right? So this low is the index of the list from where we have to start searching, and this high is the bound of that index. So basically we have to these 2 parameters are basically saying that I am going to search for this element in this array starting from the index of this going till the index of this, right? I'll repeat that. I am going to search for the element this in this array from this index of the array till this index of the array. So the definition is basically saying that. And let's for now just ignore this base case. And what we are defining a variable which is mid, and what this basically captures is the low and high by 2. So we are doing this floor division to get an integer as output. So we are basically summing up the lowest index and highest index of that array, and we are dividing it by 2, which basically means we are finding the mid, what you say, mid index of that array. Okay, so if array of mid, so if the mid element of that array is the target that we are looking for, then return true. Okay, if the element is in right in the middle, then return true. We found that element. So if that element is not there in the middle, what we do is we check whether the element that we are looking for is less than the middle element or not. The same way that we checked here. We checked whether 2 is less than 35 or not, right? So the same way we are checking whether the target element is less than the mid element or not. So if it is less than the mid element, we basically call the binary search with the same array as input, the same target, but we check from the low, which is 0. So we check from the first element up till the mid element. Okay, so that's what we mentioned here. So we, as we have already checked the mid element, we need not go till mid. So we stopped before the one element before mid. So that's why we mentioned mid minus 1. So if the target element is less than the middle element of that array, we run the binary search with the list from the starting index till the middle index, right? So we are sure that it will somewhere be in this part of the list only. Okay. So the other case where the target element is greater than the middle element, then we run the binary search with the list from the middle index to the last index. So if let's say we are searching for 89, okay, we are searching for 89 and this 89 is greater than 35. So we are sure that 89 will be in this half of the list. So that's what we did in this line. Okay. So now, so that's what we have mentioned here. We've given this list to binary search, and we have told that I want to search for element 6 from starting from the 0th index till the last index of the list. And this, when will it basically stop? It basically stops when this low means the starting element gets higher than the highest index. So this condition happens only when you don't find that particular element in this whole list. Okay, this condition will be true only when you don't find any element, that target element in that list. Okay, so that's why we wrote that as the base case. Okay, so it may take a little bit of time to digest all of this. I'll provide this collab notebook link in the description. Please go through it once. Please try it for yourself. Please be patient and practice. These are not at all tough concepts. These are very easy ones. You'll get it through practice. Okay. Okay, so these are basically the concepts which are there in week 8. So yeah, that's all for today. Thank you for watching the video, and let us meet in the next video where we'll discuss week 9 concepts. Thank you.